Okay guys, so again, the unit is mathematical models. Our objective is graphing a function in depth. Okay, so I know we already talked about graphing a function, but this is just a little bit of revision and some step-by-step things that will help you when graphing a function. Okay, so when you're graphing a function, the first thing you have to do is draw your x and y axes, right? So your x-axis is the one that's horizontal, okay? Horizontal means laying flat. And then your y-axis is the one that goes up and down, okay? It's called vertical, all right? Now, something that gets confusing sometimes is knowing how to make your marks. Your marks need to be the same width throughout all of your graph, okay? So like your x's need to be the same width apart. Your y's need to be the same width apart. Now, do your y's and your x's have to be both the same? No, they don't. You could space out your y's a little bit more than you do your x's, or vice versa, okay? Either way, as long as the y's are the same and the x's are the same. They don't have to be the same with each other, okay? Now, the increments. So what I mean by increments is, so this, if I'm going to say that this is 2, then this has to be 4, this has to be 6. You can't just jump from 6 to 10. That would be bad. You need to go 2, 4, 6, 8, 10. Okay? This point in the very middle is always going to be 0, 0. So you can't just say, okay, this is going to be 10. No. The origin is always 0, 0. Okay? So the increments need to be the same. Now, do the y increments and the x increments have to be the same distance from each other? No. I could have my y going up by 2, and then I could have my x's going up by 3, 6, 9, 12, 15. Okay? Those are things that don't have to be the same with the x and the y. All right? If you have any questions about how to set up your graph, make sure that you ask, okay? And be very organized when you're doing, like, setting up your x and y axes. Take the time and use graph paper. And if you don't have graph paper, then use at least a straight edge to make your lines and try to be consistent throughout, okay? All right, moving on. Linear functions. Linear functions, you'll know that they're linear. Let's go back. Linear functions just means a line, right? It has the word line in it, okay? So linear functions, you know it's a linear function because the x in the function has a power of 1. So that just means x to the 1. And because it's x to the 1, it just means x, okay? So you shouldn't have any number up here other than a 1 if you're talking about a linear function. X will always be in the numerator as well. The numerator is the number on top. So if you're going to have a fraction, it should be x over some number or just x. You wouldn't have 1 over x. This is not a linear function. Okay? And your linear functions are either in this form or in this form. So it's y equals mx plus c. M we'll talk about later, and then c is just some number. A, b, and c are just variables representing some number. X and y are my input and output. Okay? So, graphing linear functions. The very first thing you're going to do is you're going to find the x and y intercept. For the x-intercept, y equals 0. For the y-intercept, x equals 0. Okay? Now, after you find the x and y-intercept, you draw and label your axes. So you're going to make this graph right here. Okay? After that, then you're going to label your x-intercept and your y-intercept on your graph. So you're going to plot the x-intercept point and the y-intercept point. Then you're going to draw a line through the x and y-intercept. The reason why we only need 2 points for a linear function is because I only need 2 points to make a line. Okay? Now, we're going to do an example. I have the instructions on the next page as well. Okay? So, this is our example. We have y equals 3x minus 4. Now, notice that this is in the y equals mx plus b. The m is 3, the b is negative 4. Okay? So, first thing it tells me to do is find the x-intercept and the y-intercept. Okay? So, for x-intercept, we know that it's a point, okay? And whenever you have an x-intercept, we know that the y is going to be 0, okay? We're going to find the x value, this value right here, okay? We do that by substituting in the value 0 for where we see y into the function, right? So we have y equals 3x minus 4. We're going to take the y out. We're going to replace it with a 0. And now we're just going to solve for x. Okay? So, we have 3 times x minus 4. The first thing we're going to do to get x by itself is we're going to add 4 to both sides. Okay? So I get 4 equals 3x. I divide both sides by 3 because it's 3 times x, and I get x equals 4/3. Okay, so I've found my x-intercept. My x-intercept, after I found it, is 3/4, 0. Okay, so I'm going to erase the work that I just did, so that way we have enough room to do the rest of the problems, okay? So if you need to write it down, go ahead and pause. Now, the y-intercept. We know that the y-intercept, our x, will always be 0. Okay, and now we're going to substitute in 0 for x in order to find y. So we have y equals 3 times 0 minus 4. Okay, now we're just going to evaluate. So 3 times 0 is 0. And then y equals 0 minus 4 is just negative 4. Okay, so the y-intercept is 0, negative 4. Alright, so we did the first step. That is done. Okay, we found the x-intercept, we found our y-intercept. Now we're going to draw and label our axes. So I'm going to make my lines, my axes. And my marks, first I'm going to label this one as y and this one as x, just so I don't get confused. And then I'm going to make my little, I call them ticks, just little measures. I don't have a ruler and I don't have graph paper on this thing, so I'm trying to do as evenly as possible, okay? Which is what you should do as well. And then I'm going to go up. Okay. And so now I have my ticks, I've made my x and y axes. The only thing I'm missing are the increments, right? So I need to number each of these little ticks. I'm going to go back to my x and y intercept and look at what I need. So the x-intercept I can just do by ones, right? It's not like if this was like 12 or something, then I would need to label these a different, these x values, a bigger number. But since it's just 3/4, I can just go with increments of 1. Okay? And then I'm going to do the negative side as well. -1, -2, -3, -4, -5. Okay? And then the y-intercept, it goes down to -4. I happen to have at least 4 of these ticks going on the negative side of y, so I'm good. I can just go by 1. So -1, -2, -3, -4. -5. Now, going up, I couldn't just automatically go and change it to 2, 4, 6, 8. I still have to go by increments of 1 because that's what I started with on the negative side. Okay? Now, I've made and I've drawn and labeled my axes. That's good. Now, I need to label the x-intercept and the y-intercept. So, my x-intercept is at 3/4, or sorry, it's supposed to be 4/3, isn't it? Yeah, sorry. Okay, so I'm going to go to 4/3, which is just a little bit above 1, right? So 4 divided by 3 is 1 1/3, okay, or 1.33. So that's just right about here. Now, the y value is 0, so that tells me that I have to be on this line right here. Okay, so I've made my x-intercept. Now my y-intercept. That point is going to go down here at -4. It's going to go right on the line. The whole purpose of it being called intercept is because it cuts through on the axes at that point. Okay, so I've made my 2 points. Now I get to make my line that goes through them. Okay, please understand that a line that I make is the graph of the function. Okay, and it goes on forever unless the function tells me otherwise, which it doesn't. Okay, so this is the graph of our function y equals 3x minus 4. Okay? Okay, now, moving on. When you're graphing any other functions that aren't linear, function that isn't linear, okay, that's good. Any functions that aren't linear, you're going to follow these steps. You're going to make a table of values with inputs and outputs. You're going to draw and label your axes. You're going to plot the points that you found in the table. And then you're going to join the points with a straight or smooth curve. Usually it'll be like a smooth curve. Okay, so let's do an example. And again, these steps are on the next page. So, first thing we want to do is make a table of values. So, I'm going to draw a line. that separates the x's and the y's, my inputs and my outputs. And I want to have 5 values. So this is how I make my little graph or table, whatever you want to call it. You should call it a table, sorry, not just whatever you want to call it. Okay, so my inputs are my x's, my outputs are my y's, and I always like to have a 0 in there, just so that way I know what's happening when it crosses the y-axis. And then let's just go up by 1. You could choose to do different numbers, but generally you can just do go by increments of 1. And if you look at the function as you practice, you'll be able to see that you should choose different numbers over -1, -2, -1, 1, and 2. But again, after practice, you'll see what that looks like. Okay? So, you're going to plug each of these numbers into the function and see what you get out. When I say 0 squared, I'm going to get out 0. 1 squared is 1, 2 squared is 4, -1 squared is 1, -2 squared is 4. Okay? It's very important that when you're doing these, if you're putting them in your calculator, you're writing it like this: y equals, open parentheses, -2 squared. Okay? Because this will get us 4, which is the correct answer. If you don't put it in the parentheses and you say -2 squared, like that, you're going to get out -4, which is wrong. Okay? So, you need to make sure that you're using your parentheses when you're putting this into your calculator. Okay? So we found, and we made a table of values. Now we're going to draw and label our axes. I'm starting to talk a little bit faster because I see the time. I know that it's kind of a longer video, but just gonna have to deal with that sometimes, okay? And then I'm gonna go down 1, -1. -2. See, I'm getting a little... And we want to label these X and Y. 1, gotta make sure that they're the right length, width. Okay, 1, 2, 3, 4. Okay, let's make our points. So, my input is 0, my output is 0. So I'm going to make that point. Okay, input is 1, and my output is 1. My input is 2, my output is 4. My input is -1, and I get out 1. My input is -2, I get out 4. Okay, so I've made this. According to mine, it looks like it could be a V, but I know that this right here is not the same as that. So I can't make a V, so I'm going to make it like a little smooth curve. Okay, and then I'm going to put arrows on both ends because it's a function and it doesn't tell me that I should stop anywhere. So I assume that I can put in any X and it should be okay. Okay, the only time you won't do that is if you get a non-solution, and then that means that nothing goes there, and we'll talk more about that later. Okay, so that is how you would graph something that's not linear. Now, function notation. You just take the y and replace with f of x. So like today we were going over matching the functions with the tables with the graphs. Well, you guys had f of x, or f open parentheses x close parentheses, and I told you to scratch it out and put a y. Well, this is the reason why there was an f open parentheses x. So that is how it's written, but we just say f of x. Okay? So you just take the y and replace it with f open parentheses x. Now, what that does is we can say what is f of x when x equals 3. Well, all we have to do is replace x with 3, right? So we're going to go in and we're going to say f of 3. So the function at 3 equals 3. Notice how I'm putting it in parentheses. Oops, sorry. 3, open parentheses, 3, close parentheses, minus 4. And then I would evaluate, I would get 9 minus 4, which equals 5. Okay? Now, you can do this with any number. You just got to make sure that you're using your parentheses when you input it. Okay? Notice that this f of 3 doesn't change, right? We're saying that the function is evaluated at 3. And this is what we get. All right? It is important that you keep this format because it's going to help you be very organized. Same thing over here. If we wanted to know what the value of x equals 10, okay, you would just say f of 10 equals 10 squared. All right? And 10 squared is just 100. Okay? So that's how, if it's asking you to evaluate a function at a certain value of x, you just input that in where you see x. Note that this f of 10 doesn't move anywhere. Okay? Notice how I'm keeping the same format in both of these examples. All right? Now, a function can be written with other variables other than f. Okay, so you can say h of x, you can say c of x, g of x, t of x, so on and so forth. It doesn't matter what the function is called. Okay, it doesn't have to just be f. It can be any of these, it can be any letter. Okay, the input or the independent variable can be other variables than x. So your functions can be very diverse. You can have n of t, d of a, t of z. One that you'll find a lot is v of t, that's velocity in regards to time. Okay? So we're going to do an example and it has multiple parts, so you don't have to rewrite the problem every time. Okay? So all of the next slides are going to say consider the function c of n equals 100 minus 10n. Notice how I'm verbalizing the function, okay? I'm not saying c open parentheses and close parentheses, right? I'm saying c of n, and then I state the function, okay? So the first example says, or the first problem says to calculate c of 2. So just like I told you before, you're going to take the value, and it's saying that the n is 2. So c of 2 equals, and then wherever I see n in the function, I'm just going to replace it with 2. Okay? And notice how I'm keeping the same format as I did before. 100 minus 20 equals 80. Okay? Same format as I was showing you before. Let's move on to b. Consider the point 3, comma b lies on the graph of the function c. Find the value of b. Okay? So, b is our output. All right? So, we're saying that when x equals 3, we want to find b. So, c of n, the input, which is n, which is 3 for this problem, is going to be like this. And then wherever I see n in the problem, I'm going to replace it with 3. So 100 minus 10 times 3. Okay? So 100 minus 30, which equals 70. Okay, so b equals 70. Alright, moving on to c. The point a0 lies on the graph of the function c. Find the value of a. Okay, so a is the input, 0 is the output, right? So we're saying that c of a gives us 0, right? So what I want to do is I want to find out, what does my input have to be in order for the output to be 0? Okay, so careful with what you do here. So 0, the output, which is C of A, must be 100 minus 10A, right? So the input is A. I know what the answer is, right? I know that after doing 100 minus 10A, I should get 0, okay? So now all I have to do is solve for A. So the first thing I'm going to do is I'm going to subtract 100. I get negative 100 equals negative 10A. Notice how I dropped the negative down from the first line, okay? So now I'm just going to divide by negative 10. You get A equals positive 10, okay? So that is the value of A. When I put in 10 into this function C of n, I should get out 0. All right? D, I want you to try to do on your own. I want you to try and graph the function C. And then I want you to find the domain and the range of C. Okay? Again, I apologize for having it so long. It's just that we really needed to figure out how to graph things. That way, when we move on, you guys are set. All right? If you have any questions, make sure you write them down. If you think that I messed up somewhere or you're confused by something that I did, write down where you need help or you think that I messed up. All right? Have a good evening and see you tomorrow morning.